Okay guys, in this video we're going to continue to look at the ambiguous case situation that arises when we look at side-side angle triangles, or again, remember, you can always remember that you may have an ambiguous case because if you twist this around it's angle side-side. So in these angle side-side cases that we've been looking at, how many solutions do you have and how do you know? Well, we're going to look at these as just solving them as we normally would do, and in this video we're going to come across the two solution and one solution cases, starting with the two solution case. But what I want you to know is that you can just solve these like normal. You don't have to do anything special, but know how to recognize whether or not you have a one or two solution case. And so what I'm going to do is just my best practices here. I'm going to set up my little data matrix where I organize my information just so that I can first recognize, can I use the law of sines? Do I have a side angle pair? And so what we're given in this particular case is that our angle B is 22 degrees here, and that our side opposite it is 16.8 units long, while our A is 22.42 units long. Okay, so now, first things first, I clearly recognize that I have a side angle pair, and that what I'm looking for here is going to be this capital A if I'm going to solve this particular triangle. So I'm going to put a box around this because here's the deal. We're going to come up with two triangles on this one. But we don't know that yet, right? So I'm not going to write first triangle above this, but we're going to have a couple of different boxes in this problem. Now, looking at what we have here, I'm going to set up my law of sines in order to solve for capital A. And so we would say that I have capital A here, the sine of capital A, over 22.42 units of length, 42, and that must be equal to the sine of our 22 degree angle over the length of its side opposite, which is 16.8. So let's go ahead and do our cross product here and solve out for our sine function, then use an inverse sine. So we get 16.8 sine of A is equal to 22.42 sine of 22 degrees. We're going to divide both sides by the 16.8 here, giving us that the sine of A is 22.42 sine of 22 degrees, all divided by that 16.8 that we divided both sides by. And then we're going to say that our capital A, we're going to do a sine inverse of both sides here, but it's the sine inverse of 22.42 sine 22 degrees, all over 16.8. Now I want to point something out. In our last video, when we tried to do this, it failed. And because it failed, I told you, see, there are no solutions. And you can stop right there. But the very first thing I want you to recognize in this video is that we are going to succeed. And in the moment you succeed, you need to know that in a side-side angle case, you either have one or two solutions, but you're not quite sure yet. So let's go ahead and solve for our angle here. What I'm going to do is just get this as a value on my calculator. I'm going to go ahead and start inside my parentheses here to play it safe. So I have 22.42 times the sine of 22 in my numerator. I'm going to divide that answer by 16.8. And then we're going to undo this with sine inverse. So when I do sine inverse of we have to hit second negative key to get our answer, this whole answer here. We get about 30 degrees, which is how I'm going to list this here. So 30 degrees. And the very first thing that I always instinctually do when I'm solving problems like this is once I know this, I go put it on my picture or I go put it in my data matrix if I don't have a picture. So the neat thing about this is that I know this angle A now is 30 degrees. Now, in any other particular situation, I would just say, well, let's add these up and subtract them from 180. As a matter of fact, to find angle C, that's exactly what I'm going to do right now. I'm going to say 30 plus 22 is equal to 52 minus 180, or 180 minus 52. I have to type it now because I didn't type in 180. 180 minus 52, but we get this 128 degrees. I'm going to fill this in right now. Now, I am going to go back and solve for lowercase c, but there is something that I want to mention here. The fact is that we got this angle A right here. Now, I'm going to refer to this as our discovered angle. And what I'm going to mention is this. If in a triangle, let's say I have this situation right here. I'm going to try to sketch this out the best I can. And so we're going to say, okay, here's our B, 22 degrees. Let me shorten this side a little bit here because we're calling this B this time. I'm used to this being A. We say B is 22 degrees, and across from this we have 16.8 units long. Here we have 22.42 units long and some unknown angle up here. Now, when we compare to this side or this height H here, what you would notice, and we'll do H here really quickly. Remember, H is always the side length adjacent to our given angle. So in this case, this A side, we're going to say 22.42 times the sine of our given angle, 22 degrees. What I want you to notice is this. When we do 22.42 times the sine of that 22 degree given angle, we get the fact that the 16.8 is longer than the height, but at the same time it's shorter than the 22.42 that you see here. And so the way this ends up looking is this. I wish I wouldn't have typed all that in or written all that in first, because what I'm going to do is I'm going to change the setup here. There we go. But we're going to say this. In this particular case, we have a couple of possible solutions here. And those two solutions are either that my triangle looks like this here, and that we have a 22 degree angle, that this is 22.42, and that this is 16.8. But in the other possible instance, we know that we have a 22 degree angle here. This is 22.42. This is 22 degrees, and I'm going to drop my height again, but that this side length here could still be 16.8, but be on this side, okay, whereas it was over here before. So in order to find the values in our other triangle over here, keep in mind that this triangle that you see right here, we've already kind of discovered that it was 22, 30, and of course by deduction 128 at the top. But the fact of the matter is this. I know that this is like 30 degrees right here, and if I spin this triangle's side length over here, if I rotate it this way, that this inner angle right here is 30 degrees. So here comes the biggest secret that I could share with anybody, and it is this. If this is the triangle that we have here, and that our discovered angle is 30, then this inner angle right here has to be 180 degrees minus our 30 degrees, or in other words, we're going to say, generally speaking, we're always going to take the angle that we find, the discovered angle. And we are going to subtract it from 180, because if we do, then it would leave behind this angle that could have been in this second possible triangle. So that's exactly what I'm going to do here. I'm going to say that this is my first triangle, and down here I'm going to say this is my second triangle. Now I always set up for a second triangle the moment that I'm smelling that maybe I can have a second triangle, and I'll tell you why I do this. And we'll talk about how you recognize this. But filling back in what we know from the beginning here, we knew that this was 22.42, or we know it's 22.42. We know this is 16.8. We know 22 degrees right here. But what I'm going to put this time is this, that our angle is 180 degrees minus 22 degrees. And in this particular case, that would mean that our angle is, 22 degrees. 180 degrees minus our discovered angle. I was looking at this 22 here, minus the 30 we just found. And so what we get in this particular case is 150 degrees. Now I want you to consider something. This could potentially be 150 degrees. But what do you know about the sum of all of your angles in your triangle? And it's true that all of your angles in your triangles have to sum up to 180. So in this particular case, let's say that this is hypothetically 150. Well, my first question is this even possible? So the first thing I do is I go grab my calculator and I say, well, if that's 150, then 150 plus the original 22 that I was given, I get 172. And if that were the case, if that were 172, you guys, then that would mean that if I take that away from 180, I still have some left over. And if I do have some left over, then it is possible that this triangle existed, having that leftover C be 8 degrees. So what we're going to do now is this. Because I understand that I have two separate triangles that could possibly work, we're going to solve for the missing side length C on both of these triangles here that we have. And so let's go ahead and take a look at our very first triangle here. We're going to use the side angle pair that we were given to begin with. And because I'm looking for side length C, I'm going to put it on top. But I say C over the sine of C, which is in this case 128 degrees, would be equal to, now our side angle pair here, we had 16.8 over the sine of 22 degrees. So solving this guy out here, we'd do our cross product. We'd have C times the sine of 22 degrees is equal to 16.8 sine of 128 degrees. And so C would be equal to 16.8 sine of 128 degrees, all divided by the sine of 22 degrees. So let's go ahead and work a value on this one here. We would say 16.8, let me clear this, 16.8 times the sine of 128 times, not sure why I hit divide there, times the sine of 128. This is going to give us our numerator value here, and then I'm going to divide that answer by the sine of 22. So in the first possible triangle, it's possible that that side length C is 35.3 units long if we're going to the nearest tenth. So 35.3 units long. Now in our second triangle down here, we still have the same initial side angle pair. It's just that we're assuming that our angle C here is 8 degrees in measurement, this upper angle here, 8 degrees. And so we're going to say, well, I'm looking for lowercase c, so let's put c on top. We say c over the sine of, this time, 8 degrees, and what we're going to get is still equal to 16.8 times the sine of 22 degrees. So as we normally do, let's go ahead and work our cross product here. So our cross product would give us this. We'd say c times the sine of 22 degrees is equal this time to 16.8 times the sine of 8 degrees, which we're about to divide by the sine of 22 degrees. So I'm just going to go ahead and cross this off and say that this is equal to our c value this time. So working it back on our calculator, let's go ahead and get this out. We say 16.8 sine of 8 this time, and we're going to divide that by the sine of 22 degrees. And what we end up with is a different side length here. We say 6.2. So I'm going to fill this in up here. We say 6.2 units long. And what I'm going to do is I'm going to go back up here and just kind of point out that in our first possible instance, with this angle being 22 and this one being 30 in this particular case, then our top angle here definitely would have been 128, and the side opposite it would have been 35.3 or very long. Whereas in this case, and I'll even put this up here, 35.3, and this is 128. Whereas in this case over here, we still have 16.8 on this side length here. It's kind of hard to see, 16.8, but the bottom side length this time was only 6.2 units long just because it was spun inward, and this top angle here was 8 degrees. Okay, so in terms of finding whether you have 2 or 1 triangle, here's what we're always going to do. This little trick right here. We're always going to take 180 minus our discovered angle and set up a new set of data and ask ourselves, could this be possible? So we're going to go ahead and take a look in this video at the one solution case, and you'll like this a little bit better. So we say, let's go ahead and set up our data here. Since we don't have a picture, it's always good to put it in a table. So we say measure of angle A, measure of angle B, measure of angle C. Let's go ahead and get these written out here. But we say capital A is 7. Lowercase a is 7, lowercase b is 9, and then uppercase B is our 49 degrees right here. Now, I'm going to go ahead and put a box around this. I can clearly see that the law of sines is in option here because we do have a side angle pair right here. And what we're looking for here is this measurement of angle A. Now, this is definitely a side-side angle case, so we have to be careful here. Let's go ahead and set up and knock down our law of sine. So since I'm looking for capital A, I'm going to put it on top. We say sine of A over the side length opposite is going to be the sine of B, which is 49 degrees, over the length of its side opposite here. So let's go ahead and run our cross product. 9 sine A is equal to 7 sine 49 degrees. 7 sine 49 degrees. Let's divide both sides by 9. So we have sine A equals 7 sine of 49 degrees all over 9. And then we're going to say that A equals the sine inverse of this ratio. So we'll get our calculators primed here, ready to go. Remember, if this doesn't work on your calculator, we're done. But if it does work, we could have 2 triangles or we could have 1, even though I'm telling you we have 1 here. So let's go ahead and get our 7 sine 49 on top. 7 sine 49, enter. We'll divide that by 9, enter. Let me go ahead and call this 9. There we go. And then we got to take the sine inverse of our answer here. So the sine inverse of our answer gives us about a 36-degree angle if I'm rounding this. So I say about 36 degrees. So remember what I said last time. Once you discover this, if you got a picture, go put it on the picture. If you got a data table, go put it in your data table. But the very first thing I want to do here is this. I'm going to say that this is 36 degrees, and let's go find our third angle here. So we'd have 36 plus 49. We'll subtract that from 180, so minus 180. 95 degrees. Now this is our first possible. What we're going to do now is the same thing that we did in this last one here. We're going to say we're going to take our angle that we just found and we're going to subtract it from 180 because that might be our second triangle. So I'm going to set up a second data matrix here, and I want to show you something when we set this up this time. Measure of angle B, measure of angle C. Let's go ahead and put in everything that we had before. So we had a 7, a 9. We were given this 49 right here. Except for this time, we're going to write 180 degrees minus 36 degrees. And in that particular case, let's see, 180 minus 36. 180 minus 36. I'm pretty sure it's 144. But just to show you, we get 144 degrees. Now, remember what I said. we would do this every time. If we got an answer for this first part up here, then we should probably set up a second data matrix because you may have two triangles. But my question this time is this possible? So think about a triangle where one of your angles is 144 degrees and the other one's 49 degrees. I'm going to show you something here. Because if we're going to find this third angle, well, then I got to add these first two angles up. So I get 144 plus 49. And what I want you to notice first of all is we've already exceeded 183 degrees or 180 degrees. And so when I take 180 minus 193, oh man, I get this. And so I would even write that and I would just say not possible. So what does this mean? Does this mean I have no solutions? No, but what it does mean is there's only going to be this top possible case that does actually work. And so because it is the only case that works, let's go ahead and finish this out by trying to solve for our side length C here. And we're going to start with our initial side angle pair instead of using the A's, since we solved for A and rounded it. So we're going to say C over the sine of angle C, which is 95 degrees, is equal to, now we would have 9 over the sine of 49 degrees. So running our cross product, C times the sine of 49 degrees equals 9 times the sine of 95 degrees. Dividing both sides by the sine of 49 earns us this expression right here. C is really the sine of 95, 9 times the sine of 95 degrees all over the sine of 49 degrees. So we're going to work this out here. We'll get a decimal for our side length here, and then we will have solved the one triangle case. So we have 9 times the sine of 95 degrees, enter, divided by the sine of 49 degrees, enter. So we get about 11.9. So 11.9 units. And I'm going to go put this in my data table over here, and I'm going to say that we have one triangle case. Now, before we peace out on this video, one thing that I want you to see is this. Had we done this situation truly, remember this is like our setup right here, we would have compared this to H, something that I really never ask you guys to do, but I do want you to see this here, how this side opposite our given angle would have compared. So if our given angle was B, we knew this was 49 degrees and that the side length opposite of B was 9, and this is 7, then our height here would have been our side length adjacent to our given angle times the sine of the given angle. And so all this does is it gives us an idea of how tall that height is. I'm going to say 7 times the sine of 49 degrees. But what I want you to notice here is this. The side opposite this here, 9, is longer than the height of about 5.3, but at the same time, it's longer than the 7. So you guys, the way I've drawn this is not actually how it looks. As a matter of fact, that 9 would be longer than the 7, meaning that it goes out to here, giving us only one possible case. So the bottom line is always going to be this. When you solve side-side angle using the law of sines, if your calculator tells you you get a domain error, then you simply have no solutions. But if you do get one solution here, you always want to go set up another data matrix and say that that angle could have been 180 degrees minus my given angle. And if that's the case, does a second possible triangle even work? If it does, then you got to go solve it. And if it doesn't, then you just have one triangle that works. Cheers.